In this video, we'll talk about the concept of causality a little bit more because this is key in econometrics, like we said in the last video. Now, we might encounter many different types of questions in econometrics. For example, what is the effect on on school spending on student performance? Or in other words, if you want to know whether more spending causes better student performance on average, how do we want to go about that? Another question might be that we want to understand the returns to education. So does another year of education cause an increase in wages on average, right? So in each case, we are trying to figure out causality, not correlation. But there are some underlying issues with that we'd covered in the previous video, but we'll talk about them a little more. Okay, so before we get into those examples, remember that in econometrics, when we're trying to establish causality, the notion of Ceteris Paibus, which is to say that if we can keep all other relevant factors fixed or equal, is very important to inferring or establishing that causality. Okay, so if we are able to do that, if we are able to keep those other relevant factors fixed, then sometimes we are able to establish the changes in one variable. Let's say we were interested in returns to education. So let's say if we change education, we somehow could force people to get more educated or better educated, we could maybe see some changes in another variable, which is wages or earnings. Okay, so if we're able to keep everything else constant that might be affecting wages, we might be able to infer causality. Okay, so here we have an example which says, well, what if we want to understand, does a new fertilizer increase soybean yield, right? So this is an agricultural commodity which might be influenced by many other factors other than fertilizer, right? So one way to get to this would be that you might say, well, we can run an experiment. We can take, 2 plots of land and we can put different amounts of fertilizer on it. Okay, so let's put different amounts of fertilizer on the land and we record soybean yields, right? So we could do that for many different plots of land. Hopefully the land size is equal and we record it, okay? We record these soybean yields. But then there is this underlying issue that other factors are not held fixed, right? This notion of Ceteris Paribus doesn't hold. We don't really know if this plot 1 or 2 differ in terms of land quality. So maybe this land 1 is really more fertile and this one is not. Okay, and then if we are recording yields, then we might get to some conclusions that are incorrect. Okay, so what we want to do is hold other factors fixed. There's so many other factors in this type of question, so it's almost like it's impossible to hold other factors fixed. Okay, so let's think about some of the other examples. It could be days of sunshine, days of rainfall, land quality, like we said, the parasites that exist, right? Presence of parasites or pesticides that are used, things like that. And then obviously we want to measure the effect of fertilizer. But then if the fertilizer amounts are assigned independently of other land factors that we described here, other land factors like land quality or the parasites, etc., then we will be able to use simple regression analysis to get a good estimate of the causal effect that fertilizer has on crop yield. So let's take another example, which is about returns to education. So if we want to measure or estimate the effect of another year of education on earnings, we can always think about an experiment in which we would an experiment in which we would be able to obtain experimental data, not observational data, but experimental data. And we can basically assign each child the number of years of education that they, or the highest grade that they may complete. Okay, so no more or no less than that. This could be like that experiment that we had previously, where we could randomly assign fertilizer amounts independent of the land quality. So here we are basically saying we could assign years of schooling to individuals, right? Irrespective of any other characteristics that we might know of them, right? So ignoring all of those things, we randomly assign this. And then we can eventually record their monthly earnings, monthly or annual earnings, okay? But then this type of an experiment, like I said in the previous video, is not possible. In fact, it's quite immoral. How can you give each child a certain level of education? And maybe some children get more, some children get less, right? So that's not going to be feasible. So therefore, this field of labor economics is really interested in this idea of returns to education. And typically in those, when in studying these types of questions, labor economists would rely heavily on observational data, right? So for large samples of people, there would be data collected on education, earnings, and many other factors, okay? Now, there's obviously a problem that we encounter even if we were collecting this observational data, okay? So one idea here is that, if you just look at the correlation between the level of education and earnings, and you find it to be positive, we still can't say that this is a causal relationship, okay? This is because a lot of labor studies point to the fact that family background determine the amount of schooling. So there's some underlying factor that actually determines why you get more educated, okay? Why certain people get more educated or less, okay? There also could be other factors, like people who are more capable choose to become better educated, okay? Or people who are more capable can also earn more on average. So there could be underlying factors that affect this level of education that a person has. Okay, so just seeing a positive correlation between earnings and schooling need not imply that this is actually due to schooling or your level of education. So it's very important to understand that the other confounding factors can actually explain a lot of those differences. Okay. Now, this idea that we said of confounding factors obviously exists, but there's this other problem of self-selection. Okay, and so self-selection is this idea that you're going to decide, a person is going to decide on an action based on the likely benefits or costs of taking that action. So let's assume that you think going to college is going to be better for your grades, attending class is going to be better for your grades, or attending or getting more educated is better for your earnings. Then you would self-select into getting more educated, right? So how do we control for that? Okay, so let's write this down. So self-selection is this idea. So self-selection is this idea that you're deciding on an action based on the likely costs or benefits of taking that action. Okay, so let's think about this example. Let's think about the question on if we wanted to explore the effects of attending college lectures on performance in a course. Okay, now we know that better students or more serious students on average would also are likely to attend lectures more frequently. Okay, so if we did an analysis, or we just simply looked at the correlation between attendance and performance, and we found that to be positive, that does not necessarily mean that attending lectures causes performance to be better in college. Okay, there might be this underlying reason that better students on average also attend lectures more frequently. Okay, so that makes this correlation analysis correlation's fine, but it's misleading if you're trying to infer causality from it. Okay, this is because students are self-selecting into how much how many lectures they're attending. Okay, but this is not just limited to this example. Actually, self-selection is a serious concern in the social sciences. We've taken some examples in previous videos. We talked about unemployment and the problems with surveys on unemployment, or reporting family wealth, for example, etc. Okay. And also, if you think about the soybean example that we just took, we could also think about the fact that maybe the farm assistant could put more fertilizer on better plots of land. Okay, so if we were looking at the correlation between fertilizer and yield, and we found that to be positive, that could be due to the fact that better plots of land got more fertilizer. Okay, and therefore you're having this positive relationship. And for the last example, we can take a look at this question, which says, what is the effect of minimum wages or minimum wage on employment? Okay, now oftentimes you would notice that studies in labor economics that deal with minimum wages often would use time series data or even panel data. Okay, so you have minimum wage data over time, or you have minimum wage data for individuals over time. Okay, and you can study these types of effects on unemployment. So one idea is that the correlation between minimum wage and employment is negative. Okay, the idea that if you raise the minimum wage, then employers would necessarily decrease the number of people they want to hire because their costs are going up. So, but then, from this, do we get to this idea that minimum wage laws are somehow causing lower employment? The answer is no. We really have to dig in deeper into the issue. So we definitely know that when we look at nominal wages, that looks like a step function. It goes up, but it stays at that level. The nominal wage, minimum wages stay at that level for a long time, then they go up when there's a policy change, etc. But then, if you look at real minimum wages, we can see the changes or the variation that's much, much higher than the variation in nominal wages. Okay, so even for stretches where the nominal minimum wage isn't changing, we might see that real minimum wage, which is, let's say, this is the nominal wage, we're dividing it by some sort of a price index, this is the real wage, this might be changing over time. Okay, so usually what the state legislature does or city legislature is doing is changing the minimum wage, right? So it could be that the state of California changed it, or federal legislature changed it, or city legislature changed it, and these nominal wages, right, the numerator can change. But what if all of these changes are more likely to happen during good economic times, right? So one could think that if we were looking at this, if we were looking at this correlation, right, this could obviously be positive or negative depending on our data. But let's assume for a second that this is positive. So let's say that the correlation between minimum wage and employment is positive. Okay. So if we did find that, then what can we infer then that minimum wage laws that increase minimum wage can cause people to can lead to more employment? Can we say that? Okay, there might be an underlying problem with this type of an inference. It could be that in good economic times, if this is true, that if minimum wages are going up during good economic times, that's good economic times or maybe good policies causing employment rate to be high. Okay, so even if we see a positive correlation between employment and the minimum wage, this is not inferring. We cannot infer causality. Okay, so what our hope is in the next few videos or maybe many videos in this course is to basically use multiple regression analysis to estimate causal effects and try to make it as accurate as possible, the relationship between two or more variables.